Good morning, my students. We will complete today our lesson sets. Our objective for today is to find the complement of a set in another set. First of all, we can have only complement if we have a set, a small set, subset in another big set. So if we have, for example, a set A, subset in set E, the complement of set A is the set of all elements that are belonging to E but does not belong to A. For example, I denote here in the Venn diagram, if this is the big set E and we have set A subset in it, so what is the complement of set A? It is all elements not in A but they are in E. Okay, and it is denoted by A bar. We call this A bar, or it is denoted in this form. What we will deal with A bar. Okay, so the complement of set A, it is denoted by A bar, and it is the set of all elements that belong to the big set E and does not belong to set A. For example, if we have the set E, which is 1, 2, 3, 4, and we have set A, which is 2, 3. Here we can notice that set A subset from set E, where 2 and 3 belong to set E. Now we can bring A bar. What is A bar? We said A bar is the elements that belong to E and not belong to A. What are the elements that belong to E and not belong to A? They are 1 and 4. It's like we're subtracting set A from set E. So we have A bar, it is 1 and 4. This is the set A bar. As you can notice that the intersection between the two sets A and A bar is phi, where there are no common elements. As we said, A bar is the set of all elements that does not belong to A and belong to E. So there is no intersection between A and A bar. That's why A inter A bar is phi. And if we want to find the union of A with A bar, here look at the Venn diagram. A union A bar, it is the whole set E. So A union A bar is the whole set E. We will start by exercise 1 so that we can understand. Here we have 3 sets. We have the set E 0, 1, 2, 3, 4, 5, set B 1, 2, 4, 5, and set A it's 0, 1. First, we can notice that set B and set A are subsets in set E. As you see, all the elements in B and A belong to the set E. So we can have A bar, can have B bar, etc. First, we have to start to find A enter B. So here we have, what is the intersection between A and B? We can notice the intersection is only 1. They have only one element in common, which is 1. So A enter B is 1. But A union B, we said that in the union we take all the elements in A and in B, but we take the repeated elements only one time. So you can start by A, write all the elements in A, start by opening curly bracket, then put the elements of A, which are 0, 1, then complete by the elements of B, which are 1, 2, 4, 5. Here 1, we wrote it, so we cannot write it again, so we complete by 2, 4, and 5. Now A bar, we will look at A. The elements of A are 0, 1, and we will look and set E. It is 0, 1, 2, 3, 4, 5. What are the elements that are not in A but in E? It's like we are subtracting A. We will remove 0, 1 from E. Remove 0, 1 from E, we will get 2, 3, 4, and 5. So A bar, it is 2, 3, 4, and 5. Okay, B bar, similarly, we will take the elements of B from E, which are 1, 2, 4, 5. 1, 2, 4, and 5. We will get only 0 and 3. So B bar is 0 and 3. Now here, what is A bar bar? A bar bar will return to be A. Why? Because every bar delete the other bar. Here it's like this bar will remove this bar. We will get again A. So we will write set A, which is 0, 1. So we have a rule that every bar removes a bar. Okay, here A bar, 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 3 bars. We said that every bar remove a bar. This bar will remove this bar. We will get only A bar. So A bar, bar, bar will be A bar. We will write A bar, which is 2, 3, 4, and 5. Here we have to find A union B bar. A union B bar is like we have to look to A union B, which is here, A union B, which is 0, 1, 2, 4, 5, and we will have to find the complement of A union B. So we will look at set E. What are the elements that does not belong to A union B and belong to set E? It's like we will remove 0, 1, 2, 4, and 5. We will get only 3. So A union B bar is only 3. Here A enter B bar, we will look at A enter B. Here it is 1, and we will find the complement of it. What are the elements that does not belong to A enter B and belong to E? It's like we will remove 1. Remove 1, you will get 0, 2, 3, 4, and 5. Okay. Here we have to find the A bar enter B bar. Here the bar is on A and B only. So we will look at A bar and B bar and find the intersection between them. What is the intersection between these two? The common element is only 3. So A bar enter B bar, it's 3. Here we have to find A bar union B bar. A bar union B bar, we will look at A bar and B bar and find their union. We will start by set A and write its element, which are 2, 3, 4, 5. Then write the elements of B bar, which are 0 and 3. 0, but 3 we wrote it, so we will not write it again. So this is A bar union B bar. As you can notice here, A bar union B bar, it is equal to the set A bar enter B bar. Both are 3. They are equal sets. And A enter B bar equal A bar union B bar, also because they have the same elements. They are equal sets only also. So here we can find that A bar A enter B bar equal A bar union B bar, and A union B bar equal A bar enter B bar. We can take this as a rule. This is a rule. If you want to distribute the bar on A and B, distribute the bar on A and B, and the enter will reverse and be union. As you see, A enter B bar, it's A bar union B bar. We distributed the bar on A and B, and the enter becomes union. Here also, A union B bar, the bar is above A union B. We can distribute the bar to A and B, and the union will be enter. This is a rule.